Hello students, I am Jitendra Kumar. Thus, today we will learn leveling and contouring and surveying and leveling. That it is part 1. So today in leveling we will see how to establish vertical control, then datum, after it MSL mean sea level, then benchmark and other definitions. After it principle of leveling, and then we will see some basic instrument that is used during the leveling. So leveling actually it is establishing the vertical control. How we can establish a vertical control? It is fixing some point at desired height or determining the height of some point along the surface. Fixing some point at desired height B and determining the height of point A which is on the surface. So those heights determination is establishing the vertical control. Datum. What is datum? So we are measuring anything with respect to some reference plane, some reference surface. So to measure the level, to measure the height, to measure the elevation of any point which is slightly above or slightly below the earth's surface or on the earth's surface requires some reference planes. So we are measuring the height with respect to some reference, and that reference in our surveying terminology termed as datum. Now a few things we need to see. Then only we can differentiate the curvature and horizontal line which exist on the earth. Any tangent from the earth at some point, it deviates by 8 cm in 1 kilometer curvature length. So from this point to this point, it is curvature length. Suppose it is 1 kilometer and this is tangent line. So the pupils comes down, actually this line will come down 8 centimeter from the horizontal line. So that is deviation due to curvature of earth. Sea level and mean sea level. Before discussing this, we have to see something like that. Suppose this is surface and we can consider the earth's surface as a geode surface like this. Yeah. To develop any reference plane, we need a geoid surface. It means equipotential surface. So what is naturally available equipotential surface on earth? Definitely that is the sea level. So like here, suppose this is the water body, sea part here and some sea part here and some sea part here. So the level of this sea remains constant and it creates equipotential surface, that is gravitational equipotential surface. Everywhere the equal amount of gravitational pull works. So the natural sea level may work as a reference plane to measure the levels. Mean sea level. So mean sea level, to establish the geoid or datum, it is realized or generalized by a sea level. Why? We just understood this. Because we know that water surface is also a equipotential gravitational surface. It is just sea level. Why we use mean sea level? Because the level of water always changes when it is full moon. We know it is time of high tide, and suppose there is no moon, we know that it is time of low tide. So in 1 month we are seeing the change in levels of water surface. Similarly, due to other variations also, level of sea changes. So what we can do in that situations? So mean sea level means the sea level has been observed for a period of 19 years for all its variation. It does vary and then it has been averaged out. So the average value is the mean sea level. It is not a 1 day value, actually it is 19-year average value. Mean sea level is a global datum, and a global means in terms of entire country, entire globe. Benchmark. Suppose there is a level mentioned in the railway platforms, all railway Indian platforms. Suppose in New Delhi, when you go in the railway platform, you will see that Samudra Tal se Unchai 224 meter, like this kind of things you will see there. So it represents the level of those places from sea. So that may be the benchmark. Other places also where these things is visible, like post office and other governmental agencies also shows those levels. Those are all benchmarks. There may be temporary benchmark, there may be local benchmark. Temporary benchmark is used when no reference is available and only after observation at in small parcel of land we create a temporary benchmark. Next point is reduced level. Reduced level, whenever we are referring our levels to a datum, we set them as reduced level. Reduced level could be positive or could be negative. Reduced level, it means the elevation, it means the height. What is differing? Differing is that only we measured it with the global datum. It means mean sea level. So whenever we measure anything with respect to global datum, it is reduced level. It is actually the elevation. Leveling. The meaning of leveling is from datum. We are trying to determine the elevation of or reduced level of a point, that is leveling. Level surface is nothing but creation of another geoid. Any surface you know which is parallel to the geoid is another equipotential surface, and that is the level surface. We can understand it in drawing. Like suppose this is different elevations, surfaces are there, and like suppose this is sea levels. So here suppose this is water body, here water body, here water body, here water body, these areas. So like this is point A, and here suppose this is point B, and this line is your geoid line. Any line, any surface which passes through B and also it is parallel to the existing geoid MSL surface is another geoid, and another surface at certain height which passes through point A is another geoid. So those parallel surfaces are actually the level surface. It is local geoid, you can say that. Now leveling. In order to determine the relative differences in height between two stations, like if I know the RL of A and I want to determine the RL of B, RL means reduced level. What we should do? Suppose station A and station B are close enough, so it is quite easy. We should establish a parallel geoid to this geoid, this datum line, and we can apply the principle of leveling. In another situation, when the consideration of curvature comes, in that situation again, we will create a parallel surface from the geoid, and that one will pass through the point A and another will pass through the point B. And from the leveling principle, we can find the reduced level of point B. Here in detail, you can see that how we can do the principle of leveling. So here situation is that point A and point B are relatively close to each other, and in that situation the bottom plane is that datum line is not curved yet. In reality it is curved, but consideration of curvature is negligible. So, and the line of sight created by any leveling staff, which is almost a straight line, so that two line may be parallel to each other in that situation. And from the principle of leveling, RA plus HA will be equal to RB equal to HB, and RA plus HA equal to RB plus HB implies RB equal to RA plus HB minus HA. So in that situation, RB is reduced level of point B, which can be easily found. Situation 2 is that when the curvature of Earth is in consideration, I already mentioned that we will create a parallel geoid surface. One will pass through the point A and another will pass through the point B, and then we can apply the principle of leveling, that is RA plus HA equal to RB plus HB, and it will implies that RB equal to RA plus HB minus HA. Now what kind of different instrument we can use? Two major instruments we will use. One is dumpy level and second is leveling staff. So this is image of dumpy level. Dumpy level is made of Kepler's telescope. It has eyepiece and crosshair installed inside the telescope. Now next is line of sight. The line of sight in the telescope is defined as the intersection of crosswire and center of the eyepiece. That two line is actually the line of sight. We will understand it. Like suppose this is a Kepler's telescope, roughly I am drawing, okay, and another barrel inside this one, and here inside it a crosshair placed here, and this is the eyepiece. So here we can put the eyes. So center of this line and this crosshair, when we create a line, so this line is actually the line of sight, and above it the bubble tube is installed. So when bubbles come at the middle, definitely this line of sight becomes parallel to somewhere bottom, a line which is datum line. So in this process we can say that the instrument is leveled with respect to data. This is line of sight, and it is datum line. Okay. So by establishing bubble tube at its center location, we can establish parallel line to the line of sight. How, when we see Kepler telescope, the visual will be like this. This is actually the crosshair, and this is leveling staff. And you can see 1.2 meter, 1.3 meter, 1.4 meter, 1.5, like that. Three different types of leveling staff is shown in the figure, shown in the image actually. And this horizontal line is actually gives you the reading in leveling staff during surveying. Leveling. So I initially mentioned that suppose this is a dumpy level, and station A, station B, these are close to each other. So this line, which is a datum line, actually it is a curved line, but the station A and station B are close enough, relatively closer, than in this case this curved line and this line of sight, which is definitely a straight line, will be parallel to each other. In that case, we can easily put the principle of leveling, that is RA plus HA equal to RB plus HB. Next, situation is different. There are station A and station B, and we have to find the relative levels of A and D. And A and D are considerably, the station distances is high. So in that situation, we cannot ignore the curvature of Earth, curvature of geoid, and we know that line of sight is always a straight line. So how we can perform the leveling and how we can apply the principle of leveling? We can break the A and D in small parts like A, B, B, C, C, D, D, like that, and we will create a closure stations. In closure stations, what will happen? Suppose A, B is there. In that small point, the line of sight will be parallel to the geoid, and similarly in case of BC and CD, this will happen, and we can easily determine the reduced level of A, B, C, D respectively by that principle. Thank you. The next part we will continue, and we will see some numericals problem in that related to reduced level.